So we'll continue with the application of nuclear technology, and some more applications is something which we'll look into. The very first topic that I'd like to talk about is medicine. So nuclear technology has been have boosted the medicine field in a number of ways, mostly in treating cancer and all. So there is basically a wide use of the radiation that we have, and the radioisotopes, when chosen properly, can actually be used for diagnosis and therapy. So we can actually identify a disease, at the same time we can also treat different disease. So in combination with the imaging devices, okay, this is something which we call as the tomography. It registers the gamma rays emitted from within. So if you have some kind of radioactive material inserted within the system, it will radiate gamma radiation, and studying that gamma radiation using different kind of detector can actually tell a lot about the condition of the cells within the body. So they can study the dynamic process taking place in various parts of the body, and these radioactive doses are given to the patient, and the activity in the organ can be studied either as a two-dimensional picture or using tomography. So the doses are inserted into the body, which will actually only impact that particular cell, and it will give out some kind of radiation, and that radiation can be studied to know the exact picture inside. So basically it gives a two-dimensional image. So if we just continue with the medicine topic and we look into the therapy, the therapeutic purpose, mostly radioactive iodine is used, that's I-131, okay? And it's used in a very small amount to treat cancer and other condition affecting the thyroid gland. So if there is some cancerous cell in the thyroid gland, that can be treated by using radioactive iodine. And cancerous growth are usually very much sensitive to be damaged by radiation, so which might be external. So what happens is we can actually use a gamma beam, and that source can be cobalt 60, or if it is within the body, then you can use a small gamma or beta radiation source, and that can be directly targeted to the cell and it damages the cell. So that's basically a good treatment. So in general, when we talk about something like chemotherapy and all, these are something which are on the similar lines. So short range radiotherapy is known as brachytherapy. Okay, brachytherapy. So we have this medical terms. A new field is targeted, which is called the alpha therapy, especially for the control of dispersed cancer. So these therapies which has been noted down here mostly are dealing with treatment of cancer. Next we have got something which is called sterilization. Now in hospitals, the syringes or the equipments that are being used, especially the smaller ones which are disposable more or less, needs to be sterilized every now and then. Mostly the sterilization is carried out using something which we call as autoclave, which uses some hot water stored in it, and in the steam it basically gets sterilized. But there are instruments, there are devices which are sensitive to heat. It basically may damage the instrument. So in order to avoid that, hospital uses gamma radiation to sterilize medical products and supplies. So if it is supposed to be heat sensitive, might be damaged by the heat, then instruments like syringes, gloves, clothing, and other instrument will basically be using a gamma radiation for sterilization. So this gamma radiation is again obtained from cobalt 60 source. Next we have got transport. So solar powered ships are something which we already know, but there are also something which we call as the nuclear power ships. So this is a very important part of transport, and then there are nuclear reactors for space. So if any kind of spaceship needs to be launched, a nuclear power can also be employed, and in fact is employed a number of times. And then if you consider something like fuel cell, which basically uses hydrogen, that is also a part of nuclear technology. And then of course generation of electricity, and then movement of cars. So what happens is from the hydrogen there is generation of electricity, and basically the cars will start moving. So that is actually the application of transport, application of nuclear technology in transport. So if you basically consider the nuclear reactors for space, we have something which we call as the radioisotope thermal generators, and these are usually used in space missions. So the heat is generated from there. So the heat generated by the decay of the radioactive source, the radioactive source is mostly plutonium 238, is used to generate the electricity. So in order to power on these space missions or the spaceships, okay, we need to have some kind of electricity generated, and that generation of electricity can be powered on by plutonium 238. We need minimum amount of the radioactive material for generating more power, so that way it's very convenient. So if we look into some of the space programs like the Voyager space probe or the Cassini mission to Saturn or the Galileo mission to Jupiter or the New Horizon mission to Pluto, all are actually powered by radioisotope thermal generators. So it needs a longer period of electricity to be supplied for a larger extent of time, and that can be actually achieved by using plutonium 238. So there were some Mars rovers, which is the Spirit and the Opportunity Mars rovers, and basically it has got a mix of solar panel of electricity and RTGs for heat. So RTGs can be considered as a backup or in tandem with electricity, which can be used or in tandem with the solar panel electricity, and can be used to power on the rovers which has been sent to Mars, the space Spirit and the Opportunity Mars missions. Then we have got something which we call as the environmental traces. Radioisotopes basically has a role in detecting and analyzing pollutants. So when we consider something as a pollutant in the environment, it needs to be detected. Sometimes they are not really visible to the eye, but it's there and it's very harmful to the existence. So what we do is radioisotopes are usually used. So in order to address the pollution problems, a number of nuclear technique has been applied, and the pollution problem might include something like smog formation or sulfur dioxide contamination of the atmosphere or sewage dispersal from, let's say, the ocean outfalls or the oil spills. So these are all environmental contaminants which can be traced by using nuclear techniques. So this was a small lecture because since we didn't finish the uses of nuclear technology in the last lecture, I intended to make this additional video so that we can have an entire picture of the positive effects of nuclear technology. That's all for today. Thank you.